Alrighty, hey there. Hey, good morning. Welcome to the PyQuick Basic Python class. My name is Nick Parlante, and I work in Google's NGDU group, which deals with sort of technical training and engineering. And I also have a job at Stanford, where I work as a lecturer. So the plan for today is, actually a two-day class. So this class is about just basic, useful, normal Python. And Python is sort of, it's a nice, friendly language. You can actually learn a lot of Python in 2 days. So that's the good news. This is the class where the prerequisite is not, you don't need to be like super expert engineer to come in here and learn Python. What we want is just that you have some experience in some language. So like, you have some idea what a variable is or something like that. And then Python's going to meet you halfway on this. Python, like I was saying before, it's a nicely designed language. A lot of things work pretty easily. And so you can learn a lot of Python pretty quickly. So it's a two-day class. And what's going to happen is it'll be a mix of lecture and coding sections. And I'll kind of alternate between the two. The good news, or I guess the bad news, or whatever, the news is that the class moves pretty quickly. So I'll show you a few things in lecture, kind of demonstrate a couple things. And I want to get pretty quickly to you trying that in coding. So I think really when you code it up, that's when you're going to learn it. So as I lecture through stuff, don't feel like, I don't want you to have the idea like, oh, well, you're memorizing or writing down everything that I say. So here, I'll switch to the computer here for a second. So there's for the PyQuick class, we have a whole set of written materials. Here's the PyQuick page that links to all of them. In particular, today, there's this one, PyQuick Basics. And that's pretty much what we're going to talk about today. It's pretty long. It talks about strings and lists and modules and a bunch of things I'm going to lecture about. So my goal is, in the lecture sections, just kind of pick up the basic idea of what I'm showing you. But don't feel like you need to memorize every detail of it. And then later, when we're in the lab section, you can go look at that document. You can go, oh, right, well, he said something about strings. You can sort of orient yourself a little bit and figure out how this stuff works. So there's also, I printed some copies of this basics thing, but then I didn't make quite enough before class started. So I'll go get those at the next break. So I'll also give you a printed dead tree version of this document for you to get started. All righty. So let's just get started. So Python is actually kind of an old language. It was created by a guy named Guido van Rossum, who actually works at Google. And it was created in 1990. So I think of that as like a little bit old by hip language standards. However, in the most recent years, Python seems to have gotten a lot of momentum. It's becoming pretty popular. And I think it stems from it's basically a pretty good language. I think of Python as being sort of a quick and light language. So if I have some little task, some little automation, and I just want to just bang out some code and be done, Python seems to work very well. Like it's very sort of frictionless. It just quick little things just happen very nicely. I think you would categorize Python as a scripting language. So it's similar to maybe Perl or Bash or Ruby or maybe JavaScript. That whole sort of space of languages that don't have a real heavy type system. So Python is certainly a nice example in there. Python, as I'll show you as we start messing around with Python, Python is good at sort of quick turnaround. So you can, if you have an idea or a little experiment you want to run, you just type it in and you can just try it immediately. There's not a big compile step or anything sort of slow. So I'm going to encourage you to have a development style where you have sort of quick turnaround between editing and running. And I'll demo that in a minute. So Python is certainly very appropriate for small projects, little bits of automation. Within Google, Python gets used for all sorts of little things like that. There's debate about whether or not Python is also good for huge projects, since it lacks a big type system. And I'm not going to settle that debate today. But there are certainly advocates for both sides. But certainly, as Python's a wonderful language to learn for just solving small coding problems. All right. So let me show you a little bit of Python code here. Let's see. So Python is an interpreted language. So there's this program called Python. And later on, when we write Python programs, the Python, this is called the Python interpreter. It's actually going to kind of do the running for us. So one of the nice qualities of Python is that you can just run the interpreter. So I just type Python in here. And then I can just type little snippets of code, just add it. And it'll sort of compile and run them just as we go. And so this is a marvelous way to sort of see what's going on. So I can just show you some basic Python here. So I'll assign a variable a. I'll say, a is 6. And so what the interpreter does here is what's called a read eval print loop. So I type a little bit of code to it. When I hit return, it's going to evaluate it, and then it's come back with a prompt and say like, okay, well, now what do you want to do? So if I type A, just a value, what it does is it evaluates it, and in some sense it kind of prints like, well, here's sort of the ASCII form of that, and then it comes back with the prompt. So it's very, very standard interpreter sort of thing. So couple things to notice there. Notice I didn't have to declare that I was going to have a variable A or that it was going to be an int. No. Python, it's all about quick, light. We're just like, get right to it. So just by assigning to A, that just causes it to exist. Later on, I could say, oh, well, let's have A be the string hello. OK, well, fine. So there's not a compile time type that's associated with A. Instead, A just points to whatever it points to. So right now, so I hit A here. So yeah, so now A is a string. Earlier it was an int. Though with only a little bit of lying, the way you can think about it in Python is that a value, A in this case, it points to something, an int or a string. And whatever it points to knows what type it is. That's stored at runtime. And so then as the code runs, it just uses the types of the object as they are at runtime. And we'll certainly see that theme in a lot of other cases. Let's see, I'll show you just syntactically. So there's a built-in function called len. And so if I wanted to take find the length of that string, I could say len of A. And OK, it turns out that's 5. Also, Python is case sensitive. So if I type an uppercase A, I'm going to get this error. So it says, this bottom part, I think, it's almost English. Name error. Name A is not defined. OK, well, that's telling you something. So in Python, if it comes across a variable or some other symbol which has not previously been given some value, then that's an error. And there's a little bit in contrast to some languages where if it's undefined, it's like, well, let's just use the empty string, or let's just kind of blunder ahead. Python is not that way. So this will also come up like when you go out of bounds on an array or do some other thing where it's a little bit like it doesn't seem to match up. Python will halt. And I think given experience with programming languages, since the greatest source of delays in your code working is bugs. And so it's bad, or it's been found, it's bad if a bug is sort of sitting in there hidden. Really, if there's an error, you want to know. And so Python reflects that style. So what's going to happen is we're going to do all sorts of Python. And the interpreter is a great source of doing little experiments. So for example, what's going to happen is someone's going to ask me some question about Python, and I'm just not going to know the answer. I mean, of course. But rather than admit that, what I'm going to say is, oh, that's an excellent question. Hey, let's try it in the interpreter and see. And then that way, I'm never at risk of being wrong. Well, whatever. It's just going to do whatever it's going to do. So for example, you might wonder, oh, well, what if I want to have a string and an int together? So I'll say hello plus 6. Oh, what does that do? OK, it turns out that doesn't work. I'll just mention the solution. So yeah, plus in Java that works. In some languages, in Python though, plus between a string and it does not automatically convert. Then to fix it. In the interpreter, by the way, the up arrow works. So it's sort of like in Bash, I can pull up previous lines. So it just happens if I there's an str function. So if I do str on it, then str on kind of anything, then that tries to make a string out of it, and then the plus works. I'll talk more about strings and stuff later on. But you can do that yourself, right? You can be in the interpreter, and if you have some question about, oh, well, what if I do the whatever, it's just so quick. Like, well, just fire up the interpreter and try it out. And so Python does work, I guess, I'd say, in an interactive style. And I'm being a little repetitious about this because coming from a Java or C++ background, this feature is very foreign. So it's not something you would necessarily have an instinct to do. But in Python, it works very well. So I will certainly encourage you to go that way. All right, so let me get out of this. I'll show you how to quit the interpreter the way I do it. What I do is I type the word quit, and then it doesn't work. But in the error message, it says, I'm like, oh, right, Control D. OK, good. So then I type Control. Oops. So there we go. So later on, you don't have to do it now, but later on we'll have this PyQuick directory. It's going to have a bunch of exercises for you to do. And I'll do an ls-l in here. And in particular, I've got this hello.py file. And so I'm going to use that as kind of just real basic example to start things off. One of the in order to do this class, what you want to do is you want to have a way of editing and running and switching between those two very quickly. And there's a separate handout that talks about that, so I won't repeat that in lecture. In this case, I'm going to have these two windows. So up here, I've got this whatever primitive Emacs editor, but where I can do editing in that screen, and then in this screen I can do running. So what I'd like to do This is, right here is a very basic Python program. I'd like to just talk about the parts of this thing. So up here at the very top, there's the standard user bin Python, or number sign, bang, just talking about what interpreters can use this. Today we're gonna use Python 2.4. Python 2.4 is a perfectly modern version, and this is also the official modern version used within Google. There's also a 2.5 and a 2.6, but those differences are like not real big, so I wouldn't worry about those. I would not use Python 2.2, though that is actually different. So 2.4 is 2.4. Go with that. Python 3 actually just came out, and it does have some real differences, although it's not in wide use yet. Here and there, mostly we're doing just totally straight ahead, normal, standard Python, and so that's not very different in Python 3000, in Python 3. But in a couple places, I may point out things that are going to be a little bit different in Python 3. But for the most part, the stuff we're going to do will all come through fine. The stash TT thing, I'll talk about in a second. Oh, here, let's get rid of this import sys. I'm a little ahead of myself. There. So what this says, this def main, print hello, that defines a function. So you say def, and then space, and then the name of the thing. Yeah, question? Oh, I'm sorry, it's cutting off a little bit. Oh, thank you. There we go. All right. So this is just a simple function definition. In this case, I can give it whatever name I want, but it's very conventional in Python that whatever is going to be kind of like the main thing you're going to do, you call lowercase m main. And in this case, it turns out Python has a print operator. And so you can say print and then a series of things and separate them with commas, and it prints them. So in this case, it just prints out hello. This thing at the bottom is a little unfortunate, but it's boilerplate syntax. And that is the boilerplate syntax to run the main that I defined above. And I will mention very briefly why this is here, but then you should think of it as just something that just mechanically you just put at the bottom of the file and then don't think about it too much. The way this works is that a Python program can be, in this case, hello.py. You can run it like from the command line, like I want to invoke this program. And in that case, that if statement will be true, the way the interpreter sets things up. And so since it's true, then here what it does is it's calling the main function. So actually, I can just demonstrate that. So if I go down here to my same directory. So the way you run this thing, well, there's two ways. You could type Python, the name of the interpreter, and then give it hello.py, say, hey, please run that. And then you can see here it prints hello. So there's my marvelous program functioning. In a Unixy way, the more modern thing is that you would, you have the execute bit set, and the handout talks about this a little bit. And so then you can just say whatever, hello.py, and it just runs it. So either of those techniques will work OK. All right. So in that example, I'm running it. And so then this if statement is turning out to be true, and so then it runs the main. There is this other way that you can load a Python program, where one Python module wants to load another one and use it essentially like a library, which I'm actually going to demonstrate, I think, tomorrow. And in that case, I want to load the Python module is sort of synonymous with the idea of a file in Python. I want to load it, but I don't want to run it. I just want to have its definitions available. And so in that case, this if statement will be false if I load it. And so then it'll bring the module in, but it won't run its main. So anyway, that's what that if statement is for. But for today, we're always going to run it just like hello.py, so you don't need to worry about this too much. OK, so let me show you. I'm going to add a few features to this thing, just to kind of show you some things. So the first thing I'm going to do is I want to print out the command line arguments for my main here. It's just a very common thing to want to do. And it turns out there's a module called sys. And the sys module, this is a standard Python thing. It includes a lot of sort of operating system interface type stuff. So you could access command line arguments, or you could exit the whole program, or whatever. I'll show you how to bring up the documentation in a second. In Python, the way that you refer to some external module of stuff you'd like to pull in is you have an import statement. You say import sys or import, and I'll show you a bunch of different ones over the next 2 days. And then down here, to refer to something inside of the module, you say module name, so sys, and then dot, and then you just need to know the name. In this case, it's sys.argv is the name of the command line arguments in that module. So I'm going to save that. And then down here, I'll run hello, and I'll just say like AAA, BBB, CCC, right? So those are command line arguments. So now when I run it, see it prints this out. So that is a Python list. It has so Python lists have square brackets around them. And we'll mess with this a lot more later on. In this case, this list has 4 elements in it, which is kind of the old Unix standard way of doing command line arguments. The first argument, it points to the script itself. So that's /hello.py. And then the subsequent 3 elements, these guys here, that's just, oops. These guys then just correspond to the arguments here that I passed in. So what I wanted to show you, so going back to my source code here. So far this program doesn't really do anything very useful, but I did want to show you just the idea of a module, and like, yeah, we're going to use modules a lot today. So that's how we're going to pull stuff, use code we didn't write, but call it from our program. Now, a very reasonable question is like, well, sys, like, how am I supposed to know that? Like, where did that come from? So I want to show you 2 ways that you can kind of research what a module is and what it has in it. And I'm going to show you 2 ways. There's the high-tech way, and there's the easy way. And they both work fine. So you could use either of these ways. First, I'll show you the high-tech way. All right, so I'm going to fire up the Python interpreter. And actually, in the Python interpreter, I can say import sys. I mean, it really kind of looks like a program. It's just I get to type stuff interactively. So then inside of, there are 2 functions in here. One is dir. So I can do a dir on sys. And what that does is it just kind of shows me all the symbols that are defined in there. So it's sort of an homage to DOS, I always think of, dir. And so you can see, if you didn't know about argv or whatever, you can see like, oh, exit. Oh, that's probably the exit function. And where's argv? Oh, yeah, check it out. There's argv. So there's some of these are data, some of them are code, but you can at least get a feel for what's inside of there. So dir, that's the first one. Then there's a companion called help. And what help does is it kind of pulls up sort of a Java doc, sort of a man page, documents about like, oh, what is going on with this module. And so with dir and help, you can kind of poke around a little bit and orient yourself. And what's nice, if you look at my list here, for example, I'll just use my example, there's exit. So that's sys.exit. That's a function. I can actually say help of sys.exit, and then it pulls up just help about that function. So just in Python and in lecture or whatever, I will say, oh, we'll use the blah, 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 ABC module, and I'll kind of mention a couple of functions that you need to use, but I won't give you further direction than that. And so then, which is a very realistic position to be in, what will happen is that in Python, you can use dir and help to kind of dig around and get better docs, or using this technique. Maybe I'll do another example. Remember I talked about the len function earlier? So I could say help of len, and that like gives you like, okay, not pretty scant description, but a little bit of a description about that. One thing I'll point out about this, which is a little unusual, notice when I type help len, I'm just typing len without a set of parentheses after it. And that's a kind of subtle syntactic distinction. When I say len paren hello, like that, I'm calling the len function. But when I just say len with no parens, like that, I'm just referring to the len function. I'm pointing to say, well, here is some code. Don't run it. I just want to talk about this code. Here when I call help, notice it's just len, and it's just unadorned. All righty. So let me show you. So that's the high-tech way of doing dir and help. Certainly very useful. Now I'll show you the easy way. The easy way is you go to your browser and you just go to Google and you just type Python. Like, what do we just do? I'll say Python sys exit. And then whatever, Google searches, for whatever reason, just work really well with Python. So like the first couple hits, like, yeah, it just is the docs for the Python sys exit function. Or I've been doing Python, I'll show you strings in a second. So if I say Python string, type that in. Yeah, the first hit here. So python.org is the official. So Python, I should mention, is open source and all like good modern stuff. Python.org is sort of the official Python home. And so if you see a link that's docs.python.org, Python.org has excellent documentation and tutorials and all sorts of stuff like that. And so if you get a Google search that just kind of points into that a lot of times, that's going to be a nice authoritative answer. So just doing Google actually works amazingly well. And I always feel like I'm being kind of powerful and hip if I use like dir and help to dig around. But I must admit that in fact, just doing a Google search that like any 6-year-old could do, like in fact works great. And so both those techniques are available. You have to use whichever way you like. Alrighty. So let me show you. I'm going to go back to my. I'm going to get out of here. So I want to build up the Python code inside of this function a little bit. Show you a couple of things. One thing, I'm going to show you a very common error real quick. So I'm going to comment out the import sys. So incidentally, the number sign is the comment character. So and that just goes to the end of the line. So this is a very typical way I would write this code. I'm using sys.argv, but I've forgotten to do the import. So I want to show you what that looks like. So if I say hello, I get an error. So this is a Python error trace. So the most interesting part here is maybe at the bottom. It says global name sys is not defined. Now, the error is not very specific here, but it doesn't quite know if I wanted to have a variable named sys or a module. It doesn't know. It just looks like sys to it. But it is that error like, well, I came across the symbol and it was not previously defined. So you can see that is one of the basic rules of Python, that if you're going to use a symbol, it previously needs to have been given a value. So when you see something like that and it refers to a module that you were trying to use, then what that means is, oh, right, I forgot to do the import. So if I go back here, I'll put the import back. So essentially what the import does is it takes the symbol sys and it binds it to point to something, so that then downstream when you say sys dot whatever, it's able to actually work. So let's try that. That should now work again. Okay, good. Now we're back to just printing the arguments. All right, so what I'd like to do, well, I'll show you how to build a real program out of this. So I'm going to define a hello function that does something. So I'll say hello, and let's say this will take in a string. So I'm doing a second def here. And let's say this is a name, actually. And I'll say, print hello. And then the print, you can actually separate things with commas. So if I say hello name, and you could have multiple commas, multiple things, and it sort of prints those out and puts them on a line. So what I'll do down here, actually, and what I'll set, let's put a bunch of exclamation marks after the name. All right. So that's my little hello function that has 2 lines in it, and I'll talk about the plus and the, I'm glossing over some details there, but you can sort of see what it does. And then down here, I'll call my hello function. And what I'm going to do is I'm going to pass in the first command line argument. So that was sys.argv. And that turns out the 0th element refers to the script itself, which is this is just an ancient convention. So the element that I really care about is sys.argv1 there. So I'm going to save that. And I'll see if this works. So I'll say hello Alice. Let's see. Oh, check it out. All right, so now it prints hello Alice. You can sort of see the results there. All right, so let me talk a little bit. I just want to use this as a vehicle to kind of talk about what's going on syntactically with Python. So I'll sort of go through this top to bottom. So I gave this thing an argument called name. Notice, just as with the variables, I didn't have to declare that this was a string or an int or anything like that. I just say, well, whatever. It's just called name, and it just points to whatever it points to. So arguments and variables are similar. They're both just names that point to some value. Then in Python, when you want to set off a block of code, it very often uses the colon, as you see here. So I'm going to say define this function, and there's a colon. And I'm going to go to the next line, and I'm going to have however many lines of code I want to have. Now, this brings us to Python's most sort of famous syntactic feature, which is that Python does not have any left curly brace, right curly brace notion to enclose a block of code. Instead, Python uses indentation. So notice under the def here, so the Google standard is to indent by 2 spaces, and so that's a fine thing to do for today. So under the def, this first line is indented by 2, and this next line is indented by 2. So that's what's putting them inside of that function. And there just isn't a left curly brace or right curly brace I typed to put those in there. So this is, it's a little bit controversial. I'll just give you my take on it. I think the idea is that if we were writing this in Java, here, I'll disturb all the real Python people here. I don't know, suppose it looked like this. So, sort of funny. All right, suppose we had that, right? We're blocking out the code that makes this function. But we would have indented, like we would have had one set of brain cells that was managing the curly braces and putting them in right. But then we also would have indented correctly, right? And we were raised right, and it looks terrible. So of course we would have indented correctly as well, and that would have been a second set of brain cells. So we would have been maintaining these two things kind of in parallel. But if you sort of think about it, those 2 bits of syntax would have been reflecting the same piece of information. They always would have moved in tandem. And so the Python idea is like, having 2 bits of syntax that represent the same thing, and then we're just trying to keep them in sync is dumb. Like, we want to just do the quickest, most minimal, clean thing. I mean, that's kind of what Python looks like. And so it's like, you know what? Let's just get rid of the curly braces. If we want to look right, so I'll put the colon back there, let's just have the indentation define how the blocks of code go. So I'll fill this function out to be a little longer, so you get a better feel for what indentation looks like. My advice about this is that it seems extremely foreign, weird, and slightly wrong for about the first 11 minutes that you use it. And then it's just fine. I mean, it's just basically very logical and reasonable. And it's kind of visual. And so it very quickly just seems normal. So I'd encourage you to just not worry about it. All right. So let me I want to make this function a little longer. And that'll allow me to demonstrate the indentation a little more. Yeah, question?
You have space between hello and Alice ineligible.
Oh, so yeah, the question is, where does the space come? That's a quality of the print, that when you separate things with a comma, it puts a single space between them. If I wanted to bunch those together, I could have done a plus. The plus in string space just crams them together, so that would have done. All right. So let me show you. So I want to make this a little fancier here. I'm going to put in an if statement. So let's see. I'll say if. Let's say if name, and I'll just end up showing you how Booleans and stuff work. If name is, let's say, Alice, then we'll say, I'm just going to, this won't be very meaningful. Here, we'll add some question marks on there. So I'll just start at the top here. So this is what an if statement looks like. You say if, and then you have the test, and then there's a colon, and then it has a whatever block of statements underneath it. Now, just to get with this idea of indentation, if I wanted to also do multiple things, I could say, I could set alert Alice mode here or something. The fact that those 2 lines, the print alert and these 2 lines, are underneath the if, that's what's putting them under the control of that if statement. And then here, when this line is indented back to out, that's what's putting me outside the if statement. So this is what it means to say that the indentation is significant, right? Where something is placed, left, right, does control what the code means. So that's the foreign part. All right, so let's talk about this if statement. Here I'm using equals equals. Equals equals does sort of an intuitive, deep comparison. In some languages, you kind of have to worry, well, is this a pointer comparison or whatever? In Python, you do not have to have that worry. Equals equals does what I would describe as a kind of a real comparison. It takes the thing on the left, the thing on the right, and it really fleshes them out and compares them. So it works for integers, it works for strings. Later on, I'll show you, it works for entire lists. So you could have relatively big data structures and just compare them with equals equals, and you still get a reasonable result. In C++ or Java, you always got to have the parentheses around the test. In Python, the parentheses are not required. And then, so it's regarded as the best Python style to not put them in. It's a little bit like, it's like speaking with your sort of vulgar accent. Like if you put the parens in, then everyone's like, oh, I see, one of you, C++ refugees. So you can sort of show off your modernity by like not putting them in. If you want to have a logical connectives, this is a little bit strange. The logical connectives are spelled out with letters. So or is OR, and is AND, and not is a little hard to say in English. Not isn't the thing above the 1 on the keyboard, it's NOT. So I'll say, if name is, Nick, sorry. So finally, I'll put an else in here just to show off. So I'll say else, colon. What do we do in the else case? I'll print else. Oops. Okay. So now you can sort of see the indentation, and you're really working here, and we've got this kind of modest Python program. I'll just mention, all the regular Boolean stuff. There's less than and equal, and all the kind of regular Boolean stuff works in Python as it does in other languages. There are Boolean true and false values, although those aren't used very often. The rule in Python is that if you have a pointer to something, there's a few kind of null values that count as false. So if a number is 0, that counts as false. If a string is the empty string, that counts as false. And any other value, or if the string is not empty, or if a number is not 0, then those count as true. So that's similar to how other languages do it. All right, so let me just try running this a little bit. So I guess if I run this and I say, hello, Alice, then my if statement kicks in, so I get all those question marks, and then the line below kicks in, and I get all the, it's pretty doofy looking output. But hey, at least it works. So now I'm going to show you, I'm going to make a very sweeping claim about how Python works. Python does everything at the last possible second. So in C++ or Java, it takes your code and it compiles it, and it checks it in a million different ways, and you might get a lot of different compile errors. And then only after all that compile checking, then it runs it. That's not how Python works. When you feed your Python code, like my hello.py, into Python, it just looks at it in the most superficial way. It checks pretty much nothing and just starts running it. And each line it gets to, it evaluates that line kind of in the moment. So in the moment, it looks at what those variables point to, and so, oh, you've got a string and an int here, and it just tries to do it just at the last possible second. And only at that second does it notice if there's an error. Maybe a variable is not defined, or you're calling a function that doesn't exist, or dividing by 0. I mean, all these whatever bugs. So to highlight that, I want to try calling a function here. I'm going to call a function called does not exist. Here, I'll pass in a name. Now, there is no such function. I haven't defined it. There is not a built-in called does not exist. It's just wrong. All right? That else is just incorrect. This does demonstrate a deep quality of Python. Now, if I call hello.py and pass Alice, you know what? It's going to work fine. All right? This is what I mean. What happens is Python only checks a line when it runs that line. All right? And so because it just kind of never hit this else, whatever, it just kind of never noticed that was wrong. Now, in the great, as we understand the universe, you don't get something for nothing. Well, in Python, it means there's not a big barrier between you and just like your code running. And that can be a real virtue in a lot of cases. But also, you're giving up a certain amount of checking that some languages might have done. This also means that in a more industrial strength, because Python doesn't really check a lot at compile time, for industrial code, it's more important probably to have good unit test coverage. Like you actually need to have run all the lines to see that they're correct. Now, for our 2 days, we're going to work on things that are just kind of medium-sized little utilities where, if they're incorrect, you can see pretty clearly. And so for that kind of problem, Python is a really good match. Alrighty. So let me show you. I think I'm going to go back to the Python interpreter here. And I've sort of used strings and lists and a few things informally, but I never really explained them. So I want to kind of slow down a little bit here and actually talk about how some of these things work. So the Python string type is enclosed in quotes. So there's like the string hello that I've been done. You can also actually put the string in double quotes. Or here, I'll do a different one. Isn't. Oops. That works the same. There's not a deep semantic difference. It's just your choice. You can either use single quotes or double quotes. The one difference is that inside of a double-quoted string, as I have here, you can put a single quote, like isn't there, and it just works. And likewise, if I'd use single quotes on the outside, I could put a double quote inside. There's not a real strong preference. You can kind of use whichever one you prefer. I tend to use the single quote one. It looks a little more Python-y to me. Yeah, question? What if you have a string that you want to include a single and a double quote? Excellent question. So if you want to, so let's say I'll do a double quoted one, and I want to put a double quote inside of it. So I'll say like, what would be something where I'd say like, what you do is you put a backtick in front of it. So I'd say, I love this exercise. Yeah, so that does it. Or alternately, I could have done it inside of single quotes. All right. So I showed you. Let's see. What is A? Isn't. So I showed you the len. Oops. The len function earlier. So strings also, as I think I've already done, the plus works. So if I say A plus, yay, then that puts it together. Plus puts strings together to make a bigger string. Strings in Python are what is called immutable. And that means that once a string is created, it never changes. It's like a little read-only thing. This is a pretty modern style. It's turned out to be pretty popular in a lot of languages. So for example, when I did that little plus there, if I look at the original A, it's unchanged. All right? So whenever anything you do with strings, lowercase, uppercase, I'll show you a few things, it's always creating new strings to sort of show you the result. But the original string, it's always left unchanged. So maybe what I'll do is I'll set A to, let's say, uppercase hello. Now, it turns out there are a bunch of built-in string, what are called methods. And I'll show you one now. So for example, there's one called lower. And what that does is it makes the lowercase version of a string. Now, the reason this is called a method, and this is basic object-oriented programming, just is, there's a few things that are very easy, and that's what we're going to work on for the next couple days. This points to the string, or I can think of as a string object. And with this syntax where I say pointer to thing, dot, and then the name of the method I want to run, what that means is run that method on that object. So if I had b is equal to like yay, so if I say b.lower, okay, well, it runs it on that string. Whereas when I said a.lower, then it ran it on a. So that's basic. It's a different syntax for running a piece of code called a method on an object, and that's hopefully that's going to work pretty intuitively. So what I was saying before is that strings are immutable; they're never changed. So for example, if I look at the original, so here I'll do it again. If I say a.lower, that's not changing a. That's returning to me a new string that's the lowercase version I wanted. And if I look at the original a, it's unchanged. Now, Python there are many built-in string methods. I showed you lower. I can show you, there's like a find, just for example. So if I say a.find of e, and what that does is it searches in the string for the first occurrence of that, and then returns to me the index. Now, in reality, there are probably dozens of built-in string methods, and I'm not going to demo them all in lecture. I just want you to know that there are a lot of built-in ones. And either you could look at the PyQuick handout where it talks about some of the common ones, or you could type, in Google, type Python string, or maybe Python string method, and go to the page where it lists them all. One of the reasons that software is a lot more productive than it was, say, 15 years ago, is that we've gotten better at having what I think of as sort of built-in code, like code you didn't write, but that you can call, and it just solves basic problems for you, sort of code reuse. And Python, like any modern language, actually has a lot of code already done for you. And so one of the basic skills I think of as kind of living higher on the food chain is when you're solving a problem, you don't necessarily like, oh, I'm now going to manually write a loop to solve that. Very often, your first instinct is to find a module and dig around a little bit to find some code that somebody else already wrote. It's already done, and you're going to build your solution on top of that. That's sort of a good modern technique, and it's an excellent Python technique. Python has a lot of built-in stuff, and I will, over the course of the 2 days, I will certainly point you where a lot of that code lives. Alrighty. So I haven't talked about how to look inside of a string. It turns out you can use square brackets to look inside of a string. So if I say a square bracket 0, that's the leftmost character, and a square bracket 1, that's the e, and so on. If I go out of bounds here, then that's an error. So I really need to just keep to within the bounds of the actual thing. So one last syntax I'll show you for this. This is a little less. So you can use the plus to put together. If I wanted to have a string and then whatever, I could use the plus to put together. There's another form that uses C's printf syntax, where I could say like hi %s, and the %s is a placeholder where I'd like a string to go. And I could say, like, I have, %d donuts. And so that's called a format string. And it's a good way of mixing in. You have this outer skeleton, and you want to sort of substitute in a few things. And so then you use the %, and then you combine it with what you want. So here I'll say Alice and 42. And so using this sort of % construct, you can have a string and sort of substitute values into it and to make a bigger string. This is not really ever required. You could always have gotten that result using plus to kind of put the string together, but it is fairly common to use this, so I'll just mention it. Last thing I'll say about strings is that the strings I'm showing you right here, these are not Unicode strings. Python's Unicode treatment has been like a little uneven, and in particular in Python 3 it changed a little bit. It got better. So for here, I just want you to realize, like, yeah, these are not Python strings. These are not Unicode strings, but and in the handout it talks about there's a slightly different route by which you create a Unicode string. But once you've got a Unicode string, then all the things I've showed you still work. The square brackets, the len, the dot lower, all that kind of stuff. It's the same interface. It's just you create it a slightly different way. And so I will, but for our purposes, these will work. These strings essentially are just a series of bytes. It's just a block of bytes. All right. So that's almost all I need to show you there. So I want to show you this one. How are we doing on time? Oh, excellent. I want to show you this last string feature, and then I want to block out time for our first exercise. So in order to show you this, I'm going to go to the PyQuick basics document. I'm going to, very high tech here. I'm going to attempt to, there we go. This is just possible. I'm going to try and show the interpreter and that little bit of art that I put in the handout. OK, ooh, perfect. All right. So here, I'll set a equal to hello. So I've got that same string. So in that little piece of art, all I've done is I've drawn in the index numbers. So like a lot of languages in Python, things are, if I want to number a linear sequence of things, they're numbered from 0, starting at the left. So if I refer to a square bracket 0, that's the h. This is how I should have done it before. Or a square bracket 1, that's the e. Or if I say, what's the len of this thing, that's 5. So that's just sort of conventional indexing into something. Now, Python has a syntax for referring to not just a single element in a string like this, but a kind of a subpart of it. And this syntax is going to use the colon. So the way this is going to work is if I say a, and I'll put the square bracket, but I'm going to put a colon in the middle here. And then I'm going to indicate both the start and the end. So for example, if I say, well, I want you to start at 1, so that's the first index number. And then the second number is going to say it's going to go up to, but not including that one. In Python, this is called a slice. So if I say A13, that's the subpart of the string starting at the 1 and going up to, but not including the 3. This is called, so in Python it's called a slice. There's the word Pythonic is not a word I just made up. It's a real word in the nerderati. And this is a very Pythonic feature. Python likes having syntaxes which are sort of very short but crisp and express something that a common thing you might want to do. So if I wanted to say hello, I guess I could say what is it? A of 1:5. Now that's a little weird. The 5 is kind of one out of bounds there, but actually what you can do in the slice syntax is if you omit the thing after the colon, it just goes all the way through the end of the string. And if you omit the first one, it starts at the beginning. So actually, it is a truism that if I just say square bracket, colon, square bracket, well, I just get the whole of whatever it was. So this is a very handy syntax. Say, for example, if I want to remove the first letter, I could just say 1 colon. So instead of starting at 0, start at 1, and then just go through the end. So far that's like pretty neat. But now, just a little bit of scrolling, I'll show you the slightly other crazy thing it does. So thus far, I've just used the positive numbers. But in Python, they also added a second set of numbers that also index into the string. So this is just using the negative numbers. And the negative numbers, instead of starting at the left, they start at the right. So -1 refers to the rightmost character, and -2 refers to the next one in, and -3, and so on. You can think of it essentially as there's an implicit len there. The -1 essentially is saying len -1, right? So len in this case is 5, len -1 is 4. I'll check it out 4. So if you've ever written code in a zero-based system, it means that referring to things that happen to be at the left is very convenient, because like 0, 1, 2, you always know where you are. But then referring to things at the right is like a pain, because you always have to add len and subtract something. So the negative number scheme just also makes it convenient to refer to things on the right-hand side. And they work in slices too. So for example, how might I say that I want to omit? Well, here, first I'll just do my earlier example. So I could say, what was it? -4 colon -2. Oops. I'll put the A there. Now, that's exactly equivalent to the one where earlier it was 1 colon 3. Right? The -4 is just another way of saying that. Now, let's look at a more realistic example. Say, for example, I wanted to omit the last 3 characters of a string. I didn't know how long it was. I could just write that as colon -3, right? That it's going to go up to, but not including. I know -3 is the third in, so then I get he. Or I could do it the other way. What if I only want the last 3 characters of a string? I can just write that as -3 colon. So it just, I think syntactically, this is maybe looks a little bit weird, but I found slice syntax I found is just useful in a lot of situations. So I would encourage you to go ahead and actually learn this one. And we're going to have all these exercises and stuff in a little bit. Certainly, I have hidden inside of there little opportunities for you to end up wanting to use the slice syntax. So that is a nice way to get this stuff going. OK, so that actually concludes the first lecture section. So what I would like you to do is pull up the exercises. And so if you go to the PyQuick page, which I'll just do here, it points to this page, PyQuick exercises. There we go. And then that explains how you copy, and I can, if you raise your hand, I'm happy to kind of walk around, how you can copy this set of directories. It's going to look like this. Let me show you what I want you to do. So inside of here, there's like day 1, day 2, and some other stuff. Today we're doing day 1. So go in the day 1 directory. And the first thing I want you to look at is there's this, there's a file in there called, oops, no, not that one. There's a file in there called string1.py. And I'm just going to look inside of there. And so what this thing has is in the comments, I'll make this a little bigger. There's some little exercises in here that just use the stuff in lecture that we've done so far. So for example, here's exercise A, Dr. Evil, and just in English, there's a little description of like what it is I want you to do, and it gives a little example, but then the code is just not done. And so your job is fill in the code there to actually compute what it's supposed to compute. And there's a few of these things. And then at the bottom, I have filled in little bits of test code. And so you don't have to touch that. That's already done. That's just going to call the functions above and just kind of check that they return the right thing. So it's kind of a primitive form of unit testing. So if I run this thing right now, what it does is they all fail. Because, yeah, there's no code. And so what's going to happen is, as you fill those bits of function in, then some of these tests should start passing. You can just run it each time to just very quickly just get feedback about how it's going. So that is string 1. I'd like everyone to do string 1. If you are just so fast or you get a little bored, there's also string 2. And string 2 just contains more. And so optionally, if you have more time to kill, I'd be happy for you to go ahead and do that. The last thing I need to point out here, let's see. I'll just look at string 1 here. There's a thing I mentioned earlier that I never explained. this -tt flag. What that refers to is in a Python file, what I would recommend is that you just always indent with spaces. That is the Google standard. Just always indent with 2 spaces, and you're OK. But in your editor, maybe by habit or whatever, you might accidentally hit the tab key. And if you have a Python file that has a mixture where it uses spaces in some places and tabs in other places, that is deeply confusing. Because visually, where the code appears to align may not correspond to how it really aligns as far as Python is concerned. So what the -tt flag does is if it ever finds a mixture of spaces and tabs, it just immediately halts, which is for when you're on your first day of Python programming, that's absolutely what you want. So this will help you find the case where what you want to do, as the handout talks about, you want to set your editor so that if you ever hit the tab key, it understands to just put in spaces. But the -tt flag will protect you if you end up making a mistake in that regard. All right. So here's what I'd like to do. It's about 10:50. So I'm going to imagine I want you to work on this. Leave maybe about a half hour for that. So that's what I'd like you to do is then go have lunch. So what I'd like you to do is be back in here. I have to do a little math here. Back in here at 1:15. And so I'm going to leave you some time for doing Python coding, and then some time for having lunch. It allows you to balance that thing. And then, of course, I'm in here to answer questions or whatever during that whole time. All right, so please go ahead and get started with that.